So we have a tennis player moving in a straight line path as shown in the graph below. You know what? You look at this and you're like, straight line path? What? You know, this is going up and down. Is it possible to be moving in a straight line path? Yeah, because look, this is a graph of this tennis player's position as a function of time, right? So here's the tennis player. So here she is. There's the 0 meter position, 0 meter, 1 meter, 2 meter, 3 meter, just like when you did the walk, right? So what happens from t equals 0 to t equals 1? What happens from t equals 0 to t equals 1? She does what? Moves out to where? To the 4 meter position. She does that in 1 second, which is pretty fast to go 4 meters in 1 second. And then what happens at 4 meters? When she's out here, then she changes direction and does what? Comes back to the 0 meter position, but then she keeps going to where? -1, -2. She goes to the -2. Now what does she do once she reaches this -2? Stays there for about 1.5 seconds, from 2.5 seconds to 4 seconds, and then she comes back to the starting point. So she is moving in a straight line, but students look at this and they're like, what? You know, how is this a straight line? How many of you were wondering that? Because you're looking at the graph. So this is a plot of her position as a function of time. Okay, so we want to find her average velocity from 0 to 1. So 0 seconds is, let me change this. So 0 seconds is right here, and then 1 second is up here. So how do we find the average velocity between 2 points? Connect the 2 points with a straight line, and then take the slope. And this is nice because, you know, every part of this graph is a straight line. So the way you do part A is you go average velocity is displacement over time, which is the slope, right? Look, the rise, what's the rise?
4.
Yeah, it's 4, but that's the delta x, right? It's the change of position. From here to there is the change of position. Okay, what's the run? I mean, I know it's 1, but what is it? It's the change of time. So here's the slope. So this is going to be 4 meters over 1 second, which gives 4 meters per second. Okay, B, from 0 seconds to 4 seconds. So let me revert this again. Okay, so 0 seconds is here, 4 seconds is there. So we're going to connect the 2 points with a straight line, and we're going to take the slope of that line, this straight line connecting 0 and 4. So for part B, average velocity, you go displacement over time. So what's the displacement from 0 seconds to 4 seconds? So look, all displacement cares about is starting point and ending point. So the starting position is 0. Where's the ending position? -2. So what was her change of position? -2 meters. Okay, then how much time did that take? 4 seconds. So that's going to be -0.5 meter per second. That's the average velocity. You get it? Okay. Part C, from 1 second to 5 seconds. So connect the 2 points with a straight line and take the slope. So for part C, average velocity, displacement over time. So what's the change of position? So where does she start? She starts here at 4, and she ends down here at 0. So it's -4. In fact, you know what you can do here if you want to be super thorough? Change is always final minus initial. Change is always final minus initial. So what's her position final? 0. Here, I'm out of room here. We'll go down here. So her final position is 0, right? Where does she end up down here? At what position? The y-axis is her position. These are her positions. 1, 2, 3, 4. Where does she end up? What's her final position? 0. So 0 minus, what was her initial position? 4. So this comes out negative. Okay? And then how much time did that take? From 1 second to 5 seconds. 4 seconds. So her average velocity is -1 meter per second. Now what does that mean? Why did the answer come out negative? Well, look. So here's the 0 meter position, 1 meter, 2 meter, right? To the right is plus, to the left is minus. So which way was she moving? Which way was she moving in this problem for part C? Is she moving to the left or to the right? To the left. In physics, plus and minus is just direction. The fact that her answer, or the fact that her velocity came out negative, tells us that she's moving to the left. Okay, and the last part, from 0 to 5. So here's 0 seconds, here's 5 seconds. So her average velocity, displacement over time. What's her displacement? From 0 seconds to 5 seconds. 0, right? Because she's starting at the 0 meter position. Where is she ending? At the 0 meter position. So she didn't go anywhere. Displacement only cares about starting point and ending point. And then the time that took was 5 seconds, but this gives 0 meter per second.